Chapter 4 Quadrilaterals. A four-sided figure is called quadrilateral. Here we can see four sides made up with line segments, and it has four angles also. So these are examples of quadrilaterals. But in these two figures, this side is just like a curve, not a line segment. Line segment means it will come straight from one vertex to the other vertex. So it is a curve, not line segments. We can say this is not quadrilateral. Then each quadrilateral have its own properties. We know that some quadrilaterals, rectangle is a quadrilateral. When the rectangle becomes all sides are equal, that is square. Again, rhombus, parallelogram, kite, etc. Different names according to its shape and properties that we can go into study in this chapter. Here the definition of a quadrilateral: a four-sided figure made up with line segments is called quadrilateral. Examples: rectangles, squares, parallelogram, rhombus, kite, trapezium, etc. These names based on its figure speciality and also properties of that particular shape. Now, quadrilaterals have different names based on its properties. First one, rectangle. Look at the properties of rectangle. All angles are 90 degree. We can see four sides and four angles. All four angles with 90 degree. Then opposite sides are equal and parallel. These two sides, opposite sides. Same way another pair. Opposite sides are equal and parallel. Then diagonals are equal and bisect each other. When we are drawing the diagonal from one vertex to the other, from this vertex to the other, same way from here, this corner to the other, it will intersect at a point. If you are giving the name for that A, B, C, D, we can name that AC is equal to BD. That means diagonals are equal. And bisect. Bisect means AO is equal to OC. These two lengths are same. BO is equal to DO. So bisect each other. Bisect means equally dividing. So these are the properties of a rectangle. All angles are with 90 degree. Opposite sides are equal and parallel. Then diagonals are equal and bisect each other. Same way in the case of square. Properties we can see here also. All angles with 90 degree and all sides are equal. AB is equal to BC and that is equal to CD. So AB is equal to, we can write AB is equal to BC is equal to CD is equal to DA. Ready. Now all sides are equal and opposite sides are parallel. These two are parallel. Same way these two are parallel. Diagonals are equal and bisect each other at 90 degree. Here the diagonals. And this bisect at 90 degree. And diagonals bisect the angles of the square. This diagonal bisecting the angles of that square. When we are drawing the diagonal, this angle B equally dividing into two equal parts. When we are drawing AC, angle A is dividing equally. Similarly, angle C also dividing equally. So these are the properties of square. Figure it out. Page number 94. Find all other angles inside the following rectangles. Now we can see here OA is equal to OB. These two sides are equal. When we are considering the triangle AOB, this triangle, these two sides are equal, which means the base angles are equal. Angles opposite to equal sides, that will be equal. So this angle also 30 degree. Now this is a triangle. We know the total or sum of all the angles in a triangle, that will be 180 degree. So 30 plus 30, 60, and the remaining 180 minus 60, it will come 120. So this angle will be 120. Now these two angles, this and this, are vertically opposite angles. We know the rule, vertically opposite angles are equal. So this also 120 degree. Then look at here, DB, it's a straight line. This is 120 degree, which means this angle is equal to one total, it's a straight line. Straight line means 180 degree. Here 120, which means this is 60 degree. Similarly, this also vertically opposite, that will come 60 degree. Now look at that. This angle is 60 degree. These two sides are equal. This is a triangle BOC. So 180 minus 60, 120, and that dividing by 2, that will come 60. So these angles are 60 degree. Similarly here also 60 degree, this also 60 degree. Now this is 120 degree, 180 minus 120 is 60, that we have to divide equally, divide by 2, it will come 30. So all the angles in this figure we will get. Similarly here also, this is 110. Opposite to that also will be 110 vertically opposite angles. Now this is a straight line. QS is a straight line. So 180 minus 110, that will come as 70. So this also will be 70. Now in this triangle POS, this angle is 110. These two sides are equal. Then these two angles, base angles, are equal. So 180 minus 110, that will come 70. 70 divided by 2, it will come 35. So this also 35. Similarly here. Now this side is, this angle is 70 degree. 180 minus 70, 110. So the remaining angle is 110, that divided by 2, it will come 55. This also 55. Same way here. Also we can see that when we are adding these two angles, 55 plus 35, we will get 90. All this is a rectangle. It's given that as a rectangle, all angles with 90 degree. So we can check that the way, all the angles with 90 degree. Second question, draw a quadrilateral whose diagonals are equal lengths of 8 centimeter and that bisect each other and intersect at an angle. Here 4 angles are given. We can do one by one. So we have to draw a quadrilateral and whose diagonals equal lengths of 8 centimeter. For that, first we have to draw a diagonal of 8 centimeter using the scale. Now you can see that 8 centimeter diagonal and mark the midpoint of that. So here the midpoint, we can mark that as O. Now the angle we have to make there 30 degree, the angle between the diagonals. So take the protractor, keep that O as the center and this is the baseline. Here we can see 30 degree we have to look at. 10, 20, 30. This is the line. And we can draw the joint that and extend that with the scale. We need that also 8 centimeter. So 4 centimeter to that side. 4 centimeter means till here. And towards here also 4 centimeter. Now we got this angle as 30 degree according to the question, 30 degree, and this 4 centimeter. This also 4 centimeter. Here 4 centimeter. This side also 4 centimeter. And when we are joining these sides, we will get the required quadrilateral. This point. And here. This is the required quadrilateral with the given measurements. We can name that A, B, C, D. So ABCD is the quadrilateral with angle between the diagonals, that is 30 degree. And the diagonal is, here we can see AC, the diagonal AC, which is equal to BD. Both are equal, and that with 8 centimeter. BD, here 4 plus 4. Till here 4, again 4. So 8 centimeter. Same way here also. So according to the question, how diagonals have equal lengths of 8 centimeter, and the angle between the diagonals, that is 30 degree. Similarly, we can do the same thing for 40 degree also. For 40 degree, first we have to draw the line 8 centimeter and mark the midpoint here, that consider as O, and take protractor. Here we need 40 degree. Angle between the diagonals, that is 40 degree. So 0, 10, 20, 30, 40. Mark that 40 degree there and take the scale. And we need that also 4 centimeter. So if you are taking from here straight 4 centimeter, first we have to join this line and take 4 centimeter from here. So till here only we need. And same way towards here also 4 centimeter. Now we got the lines, and then just join that. Now we can mark the measurements there. Can give P, Q, R, S. And this angle is 40 degree. This is the second question. And this also, here 4 centimeter, this side 4 centimeter. 4 centimeter, this also 4 centimeter. So we can write here PR, diagonal from P to R. PR is equal to QS is equal to 8 centimeter. And this angle, it is angle between the diagonal, that is 40 degree. Third one with the 90 degree. Same length for the diagonal. So 8 centimeter straight line we can draw and just mark the midpoint of that 8 centimeter. This total 8 centimeter. And this we can mark as O. Now here we need 90 degree. Take the protractor. Keep that as the center, O as the center. And 10, 20, 30, 90 here. Join that. Now we have to extend that line with 4 centimeter up and down. So we need just 4 centimeter on top. Take from here 4 centimeter. Mark that point. And extend here 4 centimeter more till here. Then join the line points. Now we can mark it here. A, B, C, D. And this is 90 degree. Now the diagonal means AC is equal to BD. And that is equal to 8 centimeter. And this angle between that 90 degree. From O till D, that is 4 centimeter. Here this also 4 centimeter, total 8 centimeter. These are the diagonals with 8 centimeter, and the angle between the diagonals that is 90 degree. Next one, 140 degree. Same way we have to draw line segment, the first diagonal 8 centimeter straight line, like the same way. You can take this in any direction, the scale, and the midpoint here, that is O. Now 140 degree. So keep the protractor there at the center. And 140 means from here 10, 20, 30, here the 140 is coming. Here 90, then 100, 110, 20, 30, 140 is coming over here. Now we need that only 4 centimeter. So just take 4 centimeter from the center till here. And 4 centimeter towards here also. And join the points. So we can mark as P, Q, R, S. And this angle is 140 degree. Here the diagonals PR is equal to SQ is equal to 8 centimeter. PR. This is 8 centimeter. This also 8 centimeter. Here 4 centimeter and this 4 centimeter, total 8. The angle between these two diagonals, that is 140 degree. Third question, consider a circle with the center O. Is the circle with any radius with the center O. Line segments PL and AM are two perpendicular diameters. So we have to draw two line segments, perpendicular line segments. Perpendicular to that. And we can name that as PL and AM. So PL and AM are perpendicular, two perpendicular diameters of the circle. What is the figure APML? So we can look, see here, this will mark as O, and OL is the radius of the circle. OP also radius. OM, that also radius. OA, that also radius. So here we can see OP is equal to OA is equal to OL is equal to OM, that same as the radius of the circle. So all these are equal. Radius of a circle everywhere that will come, that is equal length. Which means when we are joining this figure with these points, we will get like the same way. This is the figure what we are getting, APML. And here we can see all these diagonals are equal and bisecting each other, also that at 90 degree, which means it is a square. If the diagonals properties of a square, that is diagonals are equal, bisecting each other, and that bisecting at 90 degree. So all the properties of square, it's satisfying here. Therefore, we can write APML is a square. So the reason we can write here, diagonals are equal and bisect each other. Here the diagonal means here AM, which is equal to PL. That's the reason. So all the properties of that square is satisfying. Therefore, APML is a square. Fourth question. We have seen how to get 90 degree using paper folding. That is easy. Just take a paper and fold it. We can see here this is 90 degree. So by paper folding, we will get exact 90 degree when we are opening that. And get here 90 degree. Now, using two sticks. Suppose we do not have any paper, but two sticks of equal length and a thread. How do we make an exact 90 degree using this? So two sticks like the same way, same length, and then mark the midpoint of one stick, and then tie the other stick here the same way by using the thread. Move it, then you will get exact 90 degree. The same length towards here and all the four sides with the same length. When it comes, then we can see that is exact 90 degree. Fifth question, we saw that one of the properties of a rectangle is its opposite sides are parallel. Can this be chosen as the definition of a rectangle? No. In other words, is every quadrilateral that has opposite sides are parallel and equal is a rectangle. So we can write there that is not enough. No. Here also no. That one of the properties of a rectangle. And so if only the opposite sides are equal and parallel, we cannot say that is a rectangle. For example, here ABCD is a with the condition AB parallel to CD. AB and CD are equal and parallel. Same way AD and BC also equal and parallel. But ABCD is not a rectangle. For a rectangle, each angle should be 90 degree. Here the angle is not 90 degree. But all other conditions are same. Opposite sides are equal and parallel. So for a rectangle, we need each angle. All these four angles should be that as 90 degree. So we can write the conclusion. Therefore, a rectangle cannot be defined as a quadrilateral with equal and parallel opposite sides. Quadrilaterals, we already have seen two special quadrilaterals, rectangle and square, and its properties. Now next one is parallelogram. Parallelogram, which means two pair of parallel lines, AB parallel to DC and AD parallel to BC. So two pair of parallel lines, and also opposite sides are equal and parallel. AD is equal to BC, AB is equal to DC. Also AB parallel to DC, AD parallel to BC. Then opposite angles are equal. Angle A is equal to angle C. Angle B is equal to angle D. Opposite angles are equal. Adjacent angles are supplementary. Supplementary means 180 degree. Any two adjacent angles, angle A plus angle B, that is equal to 180 degree. A plus D is equal to 180 degree. Same way, C plus D. Any two adjacent angles, always when we are adding, we will get that as 180 degree. Then diagonals bisect each other. When we are drawing the diagonal, bisect, equally dividing. So the properties of parallelogram. Next one is rhombus. Rhombus with properties here, all sides are equal. All four sides are equal in length. And opposite sides are parallel. These two sides are parallel. Adjacent angles are supplementary, same as the parallelogram. Here also adjacent angles are 180 degree. Opposite angles are equal. Diagonals bisect each other at 90 degree. Diagonals bisect each other at 90 degree, and also this diagonals of a rhombus bisect its angles. This diagonal bisecting this angle in two equal parts. Same way, this diagonal bisects this angle into two equal parts. Another shape, that is kite. So for properties of kite, we can see the shape, it will come like the same way, and two pair of adjacent sides are equal. These two pair are equal. Diagonals are perpendicular to each other and longer one bisect the other. This is the longer diagonal that bisect the other. Bisect means this distance or the length is equal. And one pair of opposite angles are equal. These two angles that will be equal. Another shape, that is trapezium. One pair of opposite sides are parallel. Only these two, one pair of opposite sides are parallel. Sum of angles on non-parallel sides is 180. These are the non-parallel sides. And sum of these angles, or here, that will be 180 degree. So these are the different shapes of quadrilaterals with their names and properties. Based on that, we can do the rest of the figure it out. Figure it out, page number 102. Find the remaining angles in the following quadrilateral. Here we can see these two, P are parallel to EA. Also PE parallel and equal to RA. Two pair of parallel sides are there, which means it's a parallelogram. So we can check all the properties of parallelogram. We know that in parallelogram, opposite angles are equal. So angle P and angle A, these are opposite angles. So if angle P is 40 degree, this also will be 40 degree. Another property of parallelogram, that is adjacent angles are supplementary, which means 180 degree. Adjacent angles. So this angle is 40 degree, and sum of angle P plus angle P and angle E, that will come 180 degree, supplementary. So this angle is 40, which means the other one, 180 minus 40, 140. Same way, this also, opposite angles, 140 degree. Now we got all the angles in that. In this second figure also, same thing. This also two pair of parallel lines, which means it's a parallelogram. This angle is 110, which means the opposite angle, that also 110 degree. These two angles are supplementary, which means 180 degree. So this angle 70 degree. 110 plus 70, that will come 180. This also 70. In this figure, we can see all four sides are equal. All four sides are equal, which means that rhombus. The shape is rhombus. And we know that rhombus, the diagonal bisect the angles, its angles. This angle is 30 degree. This also will be 30 degree. Now, if we are considering this as a triangle, these two sides are equal. In triangle HUV, these two sides are equal, which means this angle is 30, this also will be 30 degree. Then sum of all the three angles in a triangle, that is 180 degree. So 30 plus 30 is 60, and the remaining, that is, this angle will be 120 degree. Similarly, here this also 30 degree, and this will be 120 degree. Here also all four sides are equal, which means that also rhombus. 20 degree, this also 20 degree. And this 120 degree, which means these two, we can consider this way also. These two sides are equal, and then in this triangle, its base angles are equal. So 20 plus 20, 40. 180 minus 40, it will come 140. So same way, this also 140 degree. Second question, using the diagonal properties, construct a parallelogram whose diagonals are of length 7 cm and 5 cm intersect at an angle of 140 degree. So diagonals with length 7 cm and 5 cm, in between the diagonals angles that is 140 degree. For that, first we have to draw a line segment with one of these diagonal 7 cm we can take. So first draw a diagonal with 7 cm and mark the midpoint of 7 cm, that means 3.5 is the midpoint. Now we need to mark 140 degree. We take the protractor and keep the center, and from here 140 degree that is coming here, and from there just join to the center we marked. We know that this is the first diagonal with the 7 cm, next one with the 5 cm. For 5 cm we need here only 2.5 cm to this direction. So mark that 2.5 and extend that diagonal to this side, 2.5 cm. So now we extended this as 2.5 cm, this also 2.5 cm. Now join these endpoints. Now what we are getting here, A, B, C, D. Here diagonal AC is equal to 7 cm and BD is equal to, from here 2.5, this also 2.5, so that will come 5 cm. And the angle in between the diagonals, this diagonal, that is 140 degree. So according to the question, the angle between these two diagonals, that is 140 degree. One of the diagonal that is 7 cm, the other one it is 5 cm. Third question, using the diagonal properties, construct a rhombus whose diagonals are of length 4 cm and 5 cm. For that, first we have to draw the same way the line segment 5 cm. First diagonal that with 5 cm and mark the midpoint of that here. Now we know that the rhombus diagonals intersect at 90 degree. So we can take the protractor and the angle mark that as 90 degree. So this angle is 90 degree. And this is 5 cm already we marked. The second diagonal that with the 4 cm. 4 cm, which means 2 cm from the midpoint towards top, and extend that 2 cm to down. Now this is 2 cm. Here this also 2 cm. Total that will come 4 cm. Now join the endpoints of these line segments. Here 2 cm only we need. So mark that 2 cm and join from there. Now here we can see A, B, C, D. A, B, C, D is the required rhombus. This with 90 degree. Here the diagonal AC is equal to 5 cm. Second diagonal BD, that is equal to 4 cm. Then we can write, therefore ABCD is the required rhombus. Here Gboard activity. Place two rubber bands perpendicular to each other forming diagonals of equal length. Join the end. We can join this the way the end. And here we are getting this, that we will look at the diagonals of that shape. Here these diagonals are equal, which means if the diagonals are equal and all sides are also equal, so we can write that AB, we are giving the name that is ABCD, or AB and these CD are equal. Then this is a rhombus, and diagonals with equal length, it will become square. All the properties, four sides are equal, diagonals are equal. If you want, we can give the name. So AC and BD are equal. AB is equal to BC is equal to CD is equal to AD. So this quadrilateral is a square. Now here when we are joining the, here the answer here, what is the quadrilateral that you get? You can write here square. In the second case, when we are joining the end points, here we can see the diagonals are not equal. All sides are equal, but the diagonals are not equal. So this is just a rhombus, not a square. So what quadrilateral will you get now? Rhombus we will get. Four sides are equal, but diagonals are not equal. If the diagonals are equal, then that will become square. Otherwise, this all sides are equal, which means rhombus. Joining triangles. Take two cardboard cutouts of an equilateral triangle of side length 8 cm. Now we can see all three sides are equal. And then when we are joining these two triangles like this way, we will get. Can you get them? Can you join them to get a quadrilateral? We can write that yes. Now, what type of quadrilateral is this? Justify your answer. Look at the quadrilateral here. All four sides are equal. Diagonals, this is 8 cm, but we can see this diagonal that is little more lengthy, longer than the other one, which means diagonals are not equal. If diagonals are not equal, that is not a square. So this quadrilateral is a rhombus with all sides are equal. If all sides are equal, so we can write this shape what we are getting when we are joining two equilateral triangle, that is a rhombus. Second part, that is take two cardboard cutouts of isosceles triangle with side lengths. Isosceles means two sides are equal. Third, that is different length. So here 8 cm, 8 cm, 6 cm, and join that. So when we are joining with 8 cm together, these two sides together, when we are joining, we will get this way the shape. 6 cm if we are joining this side, if we are joining, taking this triangle and joining here, then we will get this type of shape. Now, what are the different ways they can be joined to get a quadrilateral? Joining them in this way you get, that means the side 6 cm, and if we are joining 8 cm side, we will get this way. So two different shapes we are getting. What quadrilaterals are there? In the first shape, when we are joining the side 6 cm, we are getting this the way. Here we can see all four sides are equal. But again the diagonals are different in length. This is a longer diagonal when we are comparing with this side. So since the diagonals are not equal, so it is not a square. All sides are equal, so we can write this quadrilateral is a rhombus. In the second case, triangles joined with 8 cm of each. When we are joining the 8 cm side, we are getting the shape like this way. Now when we are considering these two as two different triangles, We can see by SS's condition, these two triangles are congruent. These two sides are equal, these also equal, and this the common side. So SS's criteria, we can write triangle ABC congruent to triangle CDA. If these two triangles are congruent, then we can compare their angles. Angle 1 here, that is equal to angle 4. Angle 2 is equal to angle 5. Angle 3 is equal to angle 6. Now, if this AC is a transversal to AB and CD. Consider these two sides and this is a transversal. Now we already know angle 1 is equal to angle 4 by CPCT. If we want, we can write here CPCT because these are congruent. And angle 1 is equal to angle 4, which means the alternate angles are equal. If when a transversal cuts two lines, the alternate angles are equal. That means these two sides are parallel. AB parallel to DC. Similarly, we can prove this also. Angle 3 is equal to angle 6, which means BC parallel to AD. So now we got these two sides are parallel and this also parallel. So opposite sides are equal and parallel. Therefore, it is a parallelogram. So we can write here the first shape, that is a rhombus. What quadrilaterals are there? This is a rhombus and this is a parallelogram. So when we are joining different sides, we are getting different way the shape and different with the different properties. So according to its properties, we can name it. This is rhombus, this is parallelogram. Here we are looking at three different cases. That means first with the equilateral triangle, only one shape we are getting. Next one with isosceles triangle, two different shapes we will get. And next one that with the scale and triangle. There we are getting different way. Each side when we are joining. First we can join this side 12, that also two shapes we will get. Now when we are joining the side 9 centimeter together, there also two different shapes, 6, two different. So all together 6 different shapes we will get. Now look at that. When we are joining these two sides 12 centimeter and there are also two different shapes we will get. This side 6 centimeter, which means this the way. So when we are getting this the side, both the side as 6 centimeter and here 9 centimeter. In that figure, ABCD is a quadrilateral with the diagonals AC and BD intersecting at 90 degree. Here one is 6 centimeter and the other one it is 9 centimeter. So this is the way it will come. This shape. There here we can see opposite sides are equal and parallel. And in this shape what we are getting, that is parallelogram. So second shape, this is parallelogram. This one it is just a quadrilateral. Now when the triangle joined with the sides 9 centimeter. So now we are considering 9 centimeter side. You will get this the way the shape. Here we can see. And here 9 centimeter, this 6 centimeter, 12 centimeter. So all sides are different. ABCD just a quadrilaterally. Now again, when we are joined this way 9 centimeter, we will get this figure. So here we can see that opposite sides are equal and parallel. So that will be a parallelogram. Now third part, again the triangles joined with the side 6 centimeter. So in each case different way the picture will come. Here this is 9 centimeter when we joined, and next is we are going to move with the 6 centimeter. So here when we are joining 6 centimeter to each other, we will get the shape like this way. And this is just a quadrilateral. Again, if we are moving that triangle in this way, if we are joining, here also joining side that is 6 centimeter, but the shape it is moving according to will be different. We will get this shape. That is in the form of a parallelogram. So we can see here in the case of scale and triangle, first we joined with the side 12 centimeter. We will get here this in the form of a quadrilateral and a parallelogram. Again with the side 9 centimeter, there also first this is a quadrilateral shape and after that a parallelogram. Then in the case of when we are joining 6 centimeter as the side, there also we are getting here say quadrilateral and a parallelogram. So different shapes when we are joining each side of that isosceles triangle. Figure it out. First question. Find all the sides and angles of a quadrilateral obtained by joining two equilateral triangles with sides 4 centimeter. So two equilateral triangle when we are joining to each other. This is one of the equilateral triangle, this is the other one. When we are joining, we know that equilateral means all three sides are equal. So for this triangle 4 centimeter, 4 centimeter, this also 4 centimeter. Same way and the second equilateral triangle, this side 4 centimeter, here 4 centimeter, again this side 4 centimeter. So when we are joining, we are getting the shape like the same. Here we can see all 4 sides are equal. And the angles of an equilateral triangle, we know that is 60 degree. All sides are equal and angles are also equal. So we can mark all the angles that with the root 60 degree equilateral triangle, equal angles. Now in this figure, when we are joining, we can see angle A is equal to, angle A is coming these two together, 60 plus 60, that will come 120 degree. Angle B 60 degree. Angle D also 60 degree. Angle C again 60 plus 60, that will come 120 degree. So these are the angles of all the angles of this quadrilateral ABCD, and all sides also here marked that is with 4 centimeter. Construct a kite whose diagonals are of length 6 centimeter and 8 centimeter. For that, first we have to take 8 centimeter and then mark the midpoint here 4. And we know that diagonals are perpendicular to each other, which means 90 degree we have to take. And this other side it is with 6 centimeter. This already we have taken, that is 8 centimeter. Now we need 6 centimeter, which means 3 centimeter on top of that line till here and 3 centimeter down. So this is 3 centimeter, here this is 3 centimeter. Now join that. Here we again give the name PQRS, and here the diagonal PR is equal to 8 centimeter, QS is equal to 6 centimeter with the diagonal intersect at 90 degree. So this is the kite, required kite. We can write therefore PQRS is the required kite. Find the remaining angles of the following trapezium. We can see these two lines are parallel. We can give the name that is ABCD here. And AB parallel to CD. and this angle is 135, then this angle will be, we know that adjacent angle, these two are parallel lines and this is the transversal. Then the interior angles of in between two parallel lines, co-interior angles are supplementary. So 180 minus 135, we will get this angle as 45 degree. Same way these two angles, this is the two lines and this is the transversal. So these two angles supposed to be supplementary. 180 minus 105 will come 75 degree. Here these two sides are parallel and these two sides are equal, which means it's an isosceles trapezium. In the case of isosceles trapezium, we know that angles opposite to equal sides are equal. So which means if we are giving the name here also, A, B, C, D, these two are equal sides, and angle opposite to equal sides, that will be same. So this is 100 degree, this also will be 100 degree. Then these two are supplementary, adjacent angles. So these two are parallel lines and this is the transversal. So this will come 80 degree. Same way here also, this is 80 degree. So first we got this one, that means the isosceles trapezium, it's the angles on the isosceles, opposite angles to the equal sides are equal. So these two are equal. These two are also equal. Draw a Venn diagram showing the set of parallelograms, kites, rhombus, rectangle and squares. Then answer the following questions. So we can draw the Venn diagram like the same way. Here the set of kites, this is the set of rhombus, in between set of squares, this side set of parallelograms and set of rectangles. From this diagram we can see that set of parallelograms is a big group, and in that itself rectangle is coming. Again the special case of rectangle, that is squares. From this side it's a kite, then rhombus and squares. Now the first question here, what is the quadrilateral that is both kite and parallelogram? Kite and parallelogram. Now we can see the rhombus is coming in both. Rhombus is coming in both kite and parallelogram. So we can write the answer for that, rhombus. Second, can there a quadrilateral that is both kite and rectangle? In this Venn diagram we can see there is no quadrilateral that both kite and rectangle. Rectangle is coming here, this part, in this. Kite is here. So there is no shape with both. No quadrilateral that is both kite and rectangle. So we can write it here, no. No quadrilateral. Next, is every kite a rhombus? So every kite is not a rhombus. No. If not, what is the correct relationship between these two types of quadrilaterals? That means kite and rhombus. What is the relationship between the kite and rhombus? So the relationship that every rhombus is a kite. We can look at here. Kite and rhombus. Every rhombus is a kite. Every kite is not rhombus. Kite is a bigger area. We can see in this figure. Rhombus is a special with some special properties of that kite. Then it will come rhombus. So the relation we can write as every rhombus is a kite. Every rhombus is a kite. Here P, pair and rods are two rectangles, which means PAIR. It's a rectangle. Rectangle means this angle is 90 degree. All angles in the case of rectangle, that will be 90 degree. Now we are considering this triangle RIO. We know this 90 degree, this 30 degree, this will be 60 degree. And the remaining, this will be 30 degree, because here rods also a rectangle. So this together it will come. This angle together, that will be 90 degree. So here 60 degree and this will be 30 degree. So IOD is equal to 30 degree. This total 90 degree. From this triangle we got this part as 60 degree, the remaining part of 90, that is 30. So angle IOD is equal to 30 degree. Construct a square with a diagonal 6 cm without using protractor. Square without using protractor. So first we are drawing the diagonal, one of that diagonal, that is 6 cm. Now this is the 6 cm diagonal. Now we don't know that the 90 degree how to take, so we have to find the midpoint of that line segment. Take more than half of that line segment. And draw an arc up and down from both the points. And then we can join that. In the same way. Now here 6 cm diagonals. This already we have taken that as 6 cm. Now we need 3 cm from here. This diagonal also supposed to be 6 cm. So till here. This is 3 cm. Here also 3 cm. Then join the sides. Now here we didn't use any protractor to draw this square. Now here we are getting a square with all sides same A, B, C, D, and diagonal with a 6 cm. AC is equal to BD is equal to 6 cm, and the angle in between, that is 90 degree. CASE case is a square. The points U, V, W, X are the midpoints of the sides of the square. What type of quadrilateral? U, V, W, X. That also a square. Find this by using geometric reasoning as well as by construction and measurement. Find other ways of constructing a square within a square such that vertices of the inner square lie on the sides of the other square, as shown in figure. Here we know that this is 90 degree, it's a square. This also 90 degree. Again, when we are joining the midpoints, we can see here square all sides are equal. CA is equal to CE. So half of that CU is equal to CV. CA is equal to CE. Then when we are taking half of that, that means half of CA, that is CU. CU is equal to CV. If these two sides are equal, its base angles that will be equal. Which means this 90 degree, this is a triangle, so this will come 45 degree. Both the angles, that is 45 degree. Similarly here also, these two are equal. This 90 degree, these two angles with a 45 degree. Now this is straight line. We know that straight line means that 180 degree. So here 45 plus 45, that 90 degree. So inside that also will be 90 degree. Then only total 45 plus 90 plus 45, that will come 180 degree. This is straight line. Similarly, we can prove here inside all four angles are 90 degree, which means this VUXW, that also a square. Eighth question, if a quadrilateral has 4 equal sides and one angle is 90 degree, will it be a square? So we can write yes. Find the answer using geometric reasoning as well as by constructing and measurement. Now we can draw the square like the same way. All sides are equal. ABCD is a quadrilateral with all 4 sides are equal and one of that angle with 90 degree. Now here by SSS criteria we can write here triangle ADB, which means these two, and CBDB. These two triangles are congruent. By SSS these two sides are equal. Opposite this also is equal and this is the common side. So when we are comparing these two triangles we can write these two are congruent. If these two are congruent, angle A is equal to angle C, that is equal to 90 degree. And angle 1 is equal to angle 2, which is equal to 3 is equal to 4. Each one it will come 45 degree. Which means this 90 degree, these two sides are equal, which means this will be 45 degree. This also 45 degree. And this together that is 90, so 45 plus 45, here also together that is 90, this also 45 degree, and here the same way, if these two are 45 then this is 90 degree. So we can prove this ABCD is a square. So here it is given all 4 sides are equal and one of this angle. First we proved these two triangles are congruent. These two sides are equal. So these two angles are 45 degree. And then from these two are congruent, angle 2 is equal to. We can compare these two triangles, then we will get all the other angles, that is 90 degree. So it is a square. Ninth question, what type of quadrilateral is one in which the opposite sides are equal? Justify your answer. Quadrilateral is one in which the opposite sides are equal. So here opposite sides are equal. Here also by SSS condition. Opposite sides are equal and this is the common side. We can say these two triangles are congruent. If these two triangles are congruent, we can compare the angles. Compare the triangles, then we will get angle 1 is equal to angle 3, angle 2 is equal to angle 4. Here AC is the transversal and this AB and DC, it's these two lines and AC is the transversal. Here we are getting angle 2 is equal to angle 4, which means, or angle 1 is equal to angle 3, which means these two sides are parallel. If the alternate angles are equal, we know that alternate angles are equal, which means these corresponding sides are parallel. Similarly, the other side also, AC is a transversal for AD and BC. Then we can see 2 is equal to angle 2 is equal to angle 4, which means the line AB and CD are parallel. So from these two sides we can write ABCD is a parallelogram. Two alternate angles are equal, then we will get it. Here AC is the transversal of lines AD and BC. Alternate angles are equal, which means these two lines are parallel. And now we are getting two pair of parallel, opposite sides are parallel, therefore ABCD is a parallelogram. Here will the sum of the angles of a quadrilateral as following is 360. So we can write that is yes, find the answer by geometry. So first we will join these 2 points like the same way. Here we can mark it like the same. Join these points and mark the angles. This is 1, here 2, 3, 4. Now look at that. This is a triangle. ADB is a triangle. Here angle A plus 1 plus 3, that is equal to 180 degree. Same way in this triangle, angle C plus 2 plus 4, that is equal to 180 degree. When we are combining these two, combine these two triangles, this triangle and these two. So we will get all that is equal to 180 plus 180. Equation number 1 and 2 when we are adding. So when we are adding here, angle A plus, here it is coming angle 3 and angle 4, which means angle B, plus angle 1 and angle 2 together, that is angle D, plus angle C is equal to 180 plus 180, 360. Now we got that angle A plus B plus C plus D is equal to 360. Sum of all the angles in a quadrilateral, that is 360 degree. So we can write the sum of all angles in a quadrilateral, that is equal to 360 degree. By measuring using the protractor also, we can check that we will get the sum of all 4 angles in a quadrilateral, always that is 360 degree. State whether the following statements are true or false. Justify your answer. First one, a quadrilateral whose diagonals are equal and bisect each other must be a square. Diagonals are equal and bisect each other must be a square. This need not be a square always. This the property of a rectangle. And so here it's given the quadrilateral whose diagonals, nothing not about the sides, nothing mentioned about the sides and the angles. So this statement, a quadrilateral whose diagonals are equal bisect each other must be a square. No, so we can mark that as false. Second one, a quadrilateral having 3 right angles must be a rectangle. So 3 right angles and the 4th angle, that will be, we know the total sum of all 4 angles in a quadrilateral, that is 360 degree. Already 3 right angles. So the remaining, that will be anyway that also right angle. So which means all angles with 90 degree, that means that will be a rectangle. So that statement is true. A quadrilateral whose diagonals bisect each other must be a parallelogram. Diagonals bisect each other. So in the case of the quadrilateral, if the diagonals bisect each other, and we can prove that the quadrilateral, that will be a parallelogram. So that statement is true. Next, a quadrilateral whose diagonals are perpendicular to each other, then that will be a rhombus. If the diagonals are perpendicular to each other, then it can be not necessary always that is a rhombus, because the diagonals may not bisect each other. In the case of rhombus, one diagonal, that will be, diagonals are perpendicular to each other, must be a rhombus. Here it's saying only diagonals are perpendicular to each other, not saying about that bisecting. So diagonals bisect each other, then only that will come as rhombus. So the given statement, that is false. Here 5th one, a quadrilateral in which the opposite angles are equal must be a parallelogram. So opposite angles of in the case of a parallelogram always are equal. So that true. Quadrilateral in which all the angles are equal is a rectangle. All the angles are equal. We know that in a quadrilateral total, that is sum of all, quadrilateral means 4 angles. So sum of all 4 angles, that is equal to 360. When we are dividing for 4 angles, each angle we will get that as 90 degree. So a quadrilateral in which all angles are equal, then that will be a rectangle. True. Isosceles trapeziums are parallelograms. Trapeziums cannot be, isosceles trapeziums not necessary that always a parallelogram. It's a non-parallel sides are also there. So it's not a parallelogram, just trapezium with one pair of parallel sides. The other side it is equal only, not parallel. So it is not a parallelogram. We can write that as false.